here is the same data set, the one that we looked at the beginning. Here are the 25 students in the class, and if you scored a 43 on the test, what was your relative standing? Well, we saw that before. You were at the 80th percentile. Okay, so you can see a dot plot here that is the same plot we looked at in the previous slide. It's showing us the distribution of scores on this test for this class. Of the 25 students, you can see how their scores are distributed throughout. Now, what if the teacher decided, you know what, question 5 wasn't fair? That's not cool. I can't ask that question. So I need to take care of that somehow in the test. I'm going to add 5 points to everybody's score. What would that do to the distribution of the scores in this class? If everybody got +5 to all scores, would that change the mean? Certainly. The mean would increase by 5 points. So the original mean of this test of the 25 students was 35.4 was the class average or mean. Now, if 5 points is added to everybody's score, would that change the mean? Certainly. And you can see down here in the adjusted, which is the +5. 5 points were added to everybody's score. Now the class mean is 40.44 rather than 35.4. Does it change the spread? Well, let's look at the dot plot for that. Remember, spread it could be measured in range or it could be measured in standard deviation. It's measuring how far apart are each score from one another. So if you look at the top one, the spread from the lowest score to the highest score. Well, now what's it done to our data set? It's just shifted everything to the right 5 units. Therefore, the spread of the data set has not changed. The standard deviation, again, which is on average, how far was each score away from the mean? So on this test in the stats class, each score on average was 8.77 points away from the mean of 35.44. Well, when we added 5 points to everybody's score, all it did was shift everything to the right 5 units. It did not change how spread out these are from one another. As you can see, the distance from this point to this point is the same as the distance from here to here. And we can see that in the range. And if we look at the mean of 40.44, the data points are the same distance away from that 40.44 in the bottom graph as they are away from the 35.44 in the top graph. It has not changed our spread at all. However, has it changed our low score? Yes, you can see the low score was 12, but when everybody got 5 points added, well, of course, the low can't be 12 anymore. Now it's 17 for the minimum. And the quartiles, the median, the minimum, the Q3, the third quartile, and the maximum have all changed by 5 units. However, interquartile range, which once again is a measure of spread, what's the distance between Q3 and Q1, has not changed. So the effects of adding or subtracting a constant to a data set, what does it do? It changes any measure of center, but it does not change the measures of spread. Okay? The spread remains the same. However, everything else got 5 added to it. The mean, the median, the minimum, the quartiles, the maximum, all increased by 5, but the spread stayed the same. As you can see in the dot plot above, that it's very clear that these data points are not any more spread out from one another than they were previously. So this is called the effects of linear transformations. If I add a constant, to every single term up here, what happens? Well, that's what we just reviewed. We could add 5 to every single student's test score and then redo all the work again. That sucks, too much work. So knowing the effects of adding or subtracting a constant is going to make our lives much easier. What happens if the teacher gave this quiz out of 50 points, but decides, you know what, in my grade book, I need to make it out of 100 points. So what happens if we double everybody's score? Or we multiply everybody's score times 2. So if we multiply times 2 everybody's score on this test, what's that going to do to our measures of center, our measures of spread? Well, let's take a look here. This would be the ×2 data. Okay. The new mean would be twice as high because everybody's score was doubled. So instead of 35.44, now we have a mean of 70.88. Standard deviation doubled, minimum doubled, Q1 doubled, medium doubled, Q3, max, IQR, range. This is an easy one. So if we multiply the measure of center, if we multiply everybody's score by a constant, in this case, we're doubling everybody's score, so the constant we're multiplying by is 2. If we multiply everybody's score by 2, then all of our important measures would also be multiplied by 2. These printouts that we keep seeing here, the N, number of observations, X bar, the mean, S of X, standard deviation, the 5-number summary, which we covered in chapter 1, the min, Q1, median, Q3, max, IQR range, that is something that we can find very easily on our calculator. Our calculator is going to call that one variable statistics. So let's take a look at our calculator here. So in order for the calculator to give us that data set or that printout, the important values that we want, the 5-number summary, the mean, and standard deviation are the ones that we're going to be concerned about most. If we go into our stat and then we hit edit, it'll bring up lists for us. You're going to love lists. The better you get at manipulating lists, the easier things are going to be for you. So I have already inputted the 25 scores from our first test, the one that we've looked at previously. Now, I would like to see how can I get the mean, the standard deviation, the median, and 5-number summary, all of that stuff quickly and easily without having to do all the calculations by hand. So once you've added the data into the calculator, just simply type the 25 scores into a singular list. We can go to stat, calc, 1var stats. Okay, stat, calc, 1var stats. And then the calculator is going to ask us, do you want me to do the work on list 1? Yes. Frequency list, never, ever, ever, never all year mess with the frequency list. If you do put something in there, put a 1. Otherwise, do not mess with the frequency list. It's just going to foul things up for you. Okay? And then we simply come down here and tell the calculator to do the work for us. Remember, the calculator is just the muscle of this program. You are the brains. You got to understand what to tell the calculator. It can do all kinds of amazing, cool stuff, but it only can do what you tell it to do. But it's super strong. It can do a lot very fast. So you notice that we have the mean listed at the top, 35.44. Yeah, that's what we keep seeing on the table. The standard deviation, S of X, is 8.77. And the number of students who took the test, 25. And then if we just scroll down here, we can see the rest of the data. It gives us the 5-number summary with min, Q1, median, Q3, max. Very beneficial in making box plots. Okay. And then we have sigma of X as well, which is the standard deviation if this was a population. But since this is not every student in the world who took this quiz, it is only the sample, we would use S of X rather than using sigma. All right, so that's just, this calculator is going to be your friend. The more you guys get comfortable with the calculator, the easier things are going to be for you. So as a quick review, if we add a constant to every term, I don't want to redo all the work. By adding a constant, we add that same constant to all of these measures except spread. Spread doesn't change by adding a constant, but if we multiply by a constant, everybody gets multiplied by that constant.